Cool. Earlier in class today, I was talking about this Pascal's triangle and this relationship between a plus b quantity squared. And I just wanted to look at some further relationships along these rows of this Pascal's triangle. So I'm just going to draw it on my page so we can see it. But what we did earlier was we took this a plus b squared and we expanded it out. We said, well, that represents a plus b times a plus b. We know that when we multiply two binomials, we use this foiling process. And so if we expand this out, we would get a squared plus ab plus ba plus b squared. And then as we combine like terms, we would end up with a squared plus 2ab plus b squared. And what I wanted to do was just draw that relationship between these coefficients, 1a squared, 2ab, and 1b squared. And to draw that relationship between Pascal's triangle, that is what we call row number 2, that is the 1, 2, 1 row. And just kind of make that connection, that 1, 2, 1 is the coefficients of these terms in that product. Now the above it is 1, 1, and the above that is 1. Now if we call this row 1, and we end up with 1, 1, and row 2 was a plus b squared, row 1 would be a plus b to the first power. And what is a plus b to the first power? Well, it's a plus b, 1a plus 1b. Now the third row of Pascal's triangle is 1, 3, 3, 1. So if we kind of follow this connection, it should set up that a plus b to the third power will be represented in Pascal's triangle row 1, 3, 3, 1. Well, let's take a look at a plus b to the third power. One thing that we can connect is a plus b to the third power is essentially the same thing as a plus b squared times another a plus b. It's 3 of them, because if we said that 2 of them can be written like this, and if we already know the expansion of a plus b squared, we know it's a squared plus 2ab plus b squared, then I just need to multiply these. And we have this process as well. I'm going to use the box method to distribute this trinomial times this binomial. And what I do with that box method again is I put one of the polynomials along one edge, 2ab and b squared. That's one edge of a box. And then the other polynomial goes along the other edge, a plus b. And then within each box will be the product of those two terms. And this is another way of just distributing. I'm really just taking a and I'm timesing it by all of these, and b and I'm distributing it. It's just a way to organize. A times a squared is a cubed. A times 2ab is 2a squared b. A times b squared is ab squared. B times a squared is a squared b. B times 2ab is 2ab squared, and b times b squared is b cubed. Now, what's nice about this box method, as mentioned before, is it kind of helps us organize our like terms, because those like terms will generally be in diagonals if the polynomials were written in a standard form. I have an a squared b and I have two a squared b's. 1a squared b plus 2a squared b's is 3a squared b's. I have a 2ab squared and a 1ab squared. 2 plus 1 makes 3. So combining these like terms, I get an a cubed plus 3a squared b plus 3ab squared plus b to the third power. And when I look at row number 3 of Pascal's triangle, the row is 1, 3, 3, 1. The coefficient 1, 3, 3, 1. So Pascal's triangle is actually revealing to me the answer to any binomial cubed will work out as 1, 3, 3, 1. 1, 3, 3, 1. Now there's lots of other patterns to notice. Notice how the A's power goes from 3 to 2 to 1. And then this last term, you could think of it as A to the 0 power because it disappears. And if we look at the B exponents, this is almost like B to the 0, B to the first, B to the second, and B to the third. So Pascal's triangle not only tells us the coefficients, but if there is variables in our polynomials, we'll know the order of the powers of those as well. 3, 2, 1, 0, and 0, 1, 2, 3. So I just wanted to kind of, I don't know, open up or unlock some really amazing connections that are out here. This isn't just some random work, but mathematics is really, it's all there. And so that's just what part of learning mathematics is. It's really learning about these patterns. So we can unpack more Pascal's triangle if you guys have any questions. But thanks for your time.